Hey everybody, it is Mrs. Gauthier and we are doing homework for 623 today. All right, so for our first problems, number 670, it says which of these shapes appear to be similar and explain how we know. All right, so we need to look at which shapes, whether we can, remember we can turn them, we can flip them, but we can't like make them larger or smaller, right, in order to be similar. So, or we can't like stretch them weird. So which ones would be similar? Well, let's see. A, first of all, that one's kind of easy, right? An A and which one? An F, right? Because we just kind of multiplied maybe by 2 or something. So these two would be similar. A and F are similar. As long as we like multiplied both sides by the same amount, which it looks like we did because we had a square here and we had a square here, they would be similar. Okay, so we've used that one and we've used this one. All right, so next let's look at B. I have this nice right triangle here. I can see for sure H is not going to be similar because it doesn't have that nice right angle here in the corner, but D does. So these two, B and D, would be similar. Okay, so we have B and D. All right, next up, let's see. C. I'm really not seeing anything that looks like C at all, like of these things that are left. So nothing's going to be similar to C. We already did D. E is this isosceles kind of looking triangle. I'm not seeing anything. Even this guy is not that same shape at all. Even if I multiplied him or shrunk him, it's not going to work. All right, so he's not similar to anything. F, G. Ooh, G looks like a nice rectangle. I do have a nice rectangle here, and they look like about the same size there. So G and I would be similar. And we know H is not going to be, I don't have any triangles that look like that, even if I turned it or flipped it or made it larger or smaller. All right, so those are our similar shapes. Number 71 says a local deli sells 6-inch sub sandwiches for $2.95. Now the deli has decided to sell a family sub that is 50 inches longer. If they want to make the larger sub price comparable to the price of the smaller sub, how much should it charge, or how much should they charge? Show all of your work. Okay, so since we know some information about the smaller sandwich, let's set up a proportion for this because I know that the 6-inch one sells for $2.95. So $2.95 for a 6-inch sub. So that goes on one side of our problem. And this is our dollar amount. Remember, we're going to have to match up a dollar amount over on this side, except I don't know how much they're going to charge for it. So that becomes my X because I don't know how much money it's going to be. I do know, though, that it is 50 inches, right? So we could have labeled this with inches here, okay? Just like that. Now you do whichever way, if you want to cross multiply, if you want to fraction bust or undo division or giant one, whatever style you want to do. I'm going to, again, cross multiply. All right, so when I multiply 6x equals, multiply my 2.95 times my 50 will give me 147.50, or sorry, 50. Okay. Then I need to get x alone, so I'm going to divide on both sides by x, or by the 6 in front of the x, trying to get x alone. And then putting that into our calculator, x is 24.58. So that means that it is going to cost, right, a 50-foot sub, or 50-inch, sorry, that would be a really long sub foot, wow. 50-inch sub will cost $24.58. All right, there we go. Next one here on 72, we have a tile pattern, and we need to draw a table, a rule, and a graph for this. So let's start with a table. We can set up an XY table over here pretty easily. Remember, we're going to include our figure 0 because we're going to need that for our rule. So even though we don't have figure 0, we're going to include it, and we're going to work backwards to make sure that we can get it. Okay, so now figure 1 has, let's see, this is 4, 5, 6 tiles in it. This guy has 4, 5, 6, 7, 8, 9 tiles. And then this guy 4, 5, 6, 7, 8, 9, 10, 11, 12 tiles. Okay, so now I'm going to ask myself, well, how many tiles am I adding on every time, right? What's my growth in my rule? I know that I'm adding on 3, right, because 6 plus 3 is 9. 9 plus 3 is 12. Yep, Another way maybe that you see it is in the tile pattern, right? So I can see from figure 1 to figure 2, how did it grow? Well, I see these 2 tiles that were added on the tail, and I see 2 tile, or 1 tile. Yeah, I see 1 tile up here. I had to look at that for a second, right? Because then I can see my original shape is right there, okay? So that shows me where my 3 tiles are being added. So I can work backwards to figure out the 0 number, right? 6 minus 3 is 3. All right, now that I have my growth and my 0 number, I can write my rule. We're going to write it in the form of y equals mx plus b. So y equals, what's my m represents, remember, my growth. Growth is 3. Then remember we have our x after that. And then our 0 number is at the end, so plus 3. So there we have our table and we have our rule. Now we need to graph, okay? So we're going to use we could graph our points, right? We could say, okay, the point 0, 3, plot it. The point 0 or 1, 6, plot it. 2, 9, plot it, right? Or we can just say, okay, I'm going to graph based on the rule, which I like because I think it's a little bit easier. All right, so I'm going to use my y-intercept. That is where it crosses this y-axis, and that's where my first point is going to go. So since this is a positive 3, on my y-axis, I'm going to come up 3 and put my first point right there. Okay, from there, since I have positive growth, there's not a negative in front of my 3 right here, because this is my growth, right? I'm going to come up 3, 1, 2, 3, and then to the right 1 for positive growth. Now I want to grow my line in the opposite direction as well. So that means from my original points, I'm coming down 3, 1, 2, 3, and over to the left 1, right, to show that positive growth. I can continue this pattern all the way through and give myself lots of points, right? Now I'm going to go ahead and connect my points because we need to connect in order to have a line, right? All right, there we go. There's our graph for y equals 3x plus 3. All right, flipping it over on to our next problem here. All right, so how many solutions does each equation have? And how can we tell? Well, we're not going to be able to tell unless we solve. So that's what we're going to do first here. All right, I don't see any parentheses, so I don't have to worry about any of that. I do have some terms that I can combine, though. On the left side here, I have a -1 tile and a 5 tile, or 5 units. So I can combine those. My 4x will stay the same. And I can do 5 minus 1, which will give me 4. So plus 4. 4x plus 3. This side I can't combine anything on my right, so I just rewrite it. All right, next, I'm trying to get my x's together. So I'm going to start by subtracting 4x on both sides, right? Because I want to get rid of this 4. So let's put them over here. Oh, wait, look at that. 4x minus 4x on both sides, that's going to be 0. So all I'm left with is 4 equals 3. Now, that is not a true statement, right? 4 does not equal 3. So we put a slash through this and we say no solution. There's our answer to this, right? How many solutions does it have? It doesn't have any. Make sure that you put that slash through. Otherwise, it would be marked wrong, even if you wrote no solution, because these are not equal to each other. Just a hint. All right, for our next one, I don't see any parentheses. I don't see any terms I can combine. So I'm just going to start solving for t. I like positive variables, so I'm going to be trying to move these variables over. So I'm going to subtract 3t on either side, which is going to leave me with 3t minus 3 equals 6, right? Because we canceled these out. All right, now I need to move my units together. And it doesn't matter if you moved your units first and then your t's, that's fine. I'm going to add 3 on both sides, right? Trying to move it over onto the other side here. So we have 3t equals 9 when we add 6 plus 3. And then our last step, hopefully you can see it if I write it really small, I have to divide by that coefficient. So dividing by the 3 on both sides. So that means 3 goes into 9 3 times, t equals 3. So this one is just going to have one solution. If it asks us how many solutions it just has one, just 3. That's the only number that'll work. All right, for part C, I see parentheses, right? That's always my first step. So if I see parentheses, I know I need to distribute. So that means I'm multiplying the 6 times everything inside of the parentheses. So 2 times 6, or 6 times 2m, would be 12m, minus, I also have to do my 6 times my 3, so that would be 18. Now, the negative 3m is going to stay the same. That's outside the parentheses, so we do not distribute anything to it. All right, and then we just rewrite everything else on this side because there weren't any parentheses. All right, second step that we need to do, combining like terms. I see that I have m's, right? Two different sets of m's here, so I need to combine those terms. 12 minus 3, don't forget the negative goes with that 3. 12 minus 3 we know is 9m. Minus 18, that stays the same because that's not part of those m's and there's nothing to combine there. All right, and then we have some m's on this side. A 2m and just an m, right? It's going to be 3 m's altogether. Minus 18. There we go. Okay, so let's move our m's first, right? And so since we like our positive m's, we're going to subtract by 3m on either side. So that is, I'm just going to rewrite up here because it's going to be a longer one. So 6m, right, when I subtract 3 minus 9, or 9 minus 3 rather, 16, or 6m minus 18, that stays the same right here, equals, okay, so this I subtracted out, equals negative 18. There we go. Now I want to move my 18 over, so I'm going to add 18 on both sides. And I end up with 6m equals 0, right? Oops, I didn't have my, there you go, equals 0. Now, I do not have my m's alone yet, so I cannot just say m is 0, right? I have to show my last step of getting all of the m's by themselves. So that means m still does equal 0, but you need to take it down to this last step, okay? Now, when m is 0, that does not mean no solution. No solution is when two numbers, like up here, do not equal each other. In this case, m does equal 0, so that means one solution. Just means that 0 is the only number, just like up here, 3 was the only number. In this equation, 0 is the only one that will make it true. All right, last one of this type. No parentheses to work with, but I do have some terms, right? The 10 and the negative 2 that I can combine, and over on the other side, I have some y's. So let's do this left side first. So 10 minus 2 we know is 8. Plus 3y equals, now I can combine some y's, right? 4 minus, when we just have a negative y, that's like a negative 1. There's like that imaginary 1 that sits out in front. So 4 minus 1 is 3y plus 8. Let's move some y's together first, right? So we could subtract 3y on either side. If you wanted to start with the 8s, you certainly could. That would leave me with 8 equals 8. Right? Oh, hey, I could take it down to 0 equals 0, but that means that any solution will work when two things are completely equal to each other. That is an any solution, meaning I could plug in any number, whether it be a billion to negative 54, any number. I could plug in a decimal or a fraction as long as it's the same. I could plug in like 0.75243, and that would still work. I'm not going to check it that way because that would take a long time, but it would still work. Alrighty, moving on to 74 here. We have some fractions, right? Just some basic fraction work here. So on these ones, first, I don't want to work with a mixed number. So I'm going to convert these to improper fractions, right? Fractions greater than 1. I'm going to do that by multiplying the whole number out front by the denominator. So negative 2 times 10 is negative 20. And then I have to add on plus 3 more. So that would be negative. That just means that the whole fraction is going to be negative. So negative 23. The denominator stays the same. So it was 10. It stays at 10. So this is this fraction right here, right? Just in a different form. And we're going to do the same thing over here. So 1 times 5. Oh, I know my fraction is going to be negative. 1 times 5 is 5. Plus 2 more is 7. Over denominator stays the same at 5. Okay. Now that I have them in fractions that I can work with, I am going to try to get a common denominator because with subtraction, I can't work with them if they have two different denominators. So it's kind of nice, right? 5 goes into 10 nicely. So I'm just going to multiply by 2 on both sides, on the top and the bottom, because I know 5 times 2 will get me to 10, which is that nice denominator for working with this fraction. So whatever we do to the bottom of a fraction, we have to do to the top to keep it balanced. So 7 times 2 is 14, and we know that this was negative, so we can't forget that negative sign right there. All right, so now if I rewrite my equation, I had this negative 23 over 10 minus 14 over 10. Now I can do my I can do my math. My denominator is going to stay the same. This is going to stay negative because I'm essentially like adding two negatives together. And when I do that, I end up with 37. I can then go ahead and put this into a mixed number because 10 will go into 37, right? So it'll go in 3 times. So negative 3 would be my whole number because it'll go in 3 times. And then how many do I have left? Well, I have 7/10 left. So 7 over 10. Okay. So that is our nice mixed number for our answer for A. All right. For B, we are dividing. I know that when I have a whole number, I can put it over 1, right? And you guys might remember your keep, flip, change. So if I have 3 over 1, then I would keep my first fraction. I would change this to multiply, and then I'm going to flip my fraction. So 4/5, right? Just like that. And then I can go ahead and I can multiply across. So 3 times 4, remembering that our fraction is going to be negative because a negative times a positive is a negative. So I just put that out front automatically. 4 times 3 is 12. 5 times 1 is 5, right? There's our nice number. Now we could, right, change it into a mixed number. 5 goes into 12 2 times, and then we would have 2 left over. So 2 2/5 would be another way to say that. All right. There's our mixed number. All right. So next one, letter C. Again, I have a mixed number, so I want to convert this right away. 5 times 8 is 40. 40 plus 7 would be 47. The denominator stays the same, so this fraction is essentially that. Now we can kind of do it nicely. So my 3/4, though, will go nicely into an 8, right, for a denominator to find a common denominator. So I know I can multiply times 2 to give me 8 here, so I have to multiply on top by 2 also, which would be 6. All right, so now my problem essentially is 6/8 plus my 47/8 equals, denominator stays the same. We just go ahead and we add our fractions here. And when we add these up, yep, we would end up with 59. Perfect. Now to make a mixed number, we would say 8 goes into 59. How many times? It goes in 6 times, right? And then how many do we have left over? Well, we would have 5/8 left. Okay. So there would be our mixed number for letter C. All right, I think there's one more, on the back side here for letter D. Let's see here. All right, so again, another mixed number. I want to convert that to a fraction that's greater than 1. So I'm going to multiply my 5 times 6, which is 30. And then I'm going to add on that one more for my numerator. So I have 31 over 6, right? And we are multiplying, so I'm just going to put parentheses, negative 7/9. We're just going to multiply these together, okay? So when we do that, remember, a negative times a positive is going to be a negative fraction. Then my 7 times 31 is going to be 217. And my 6 times 9, we know, is 54, okay? And then I can simplify this too, and I can say 54 goes into 217 how many times? And it would go in 4 times. Remember that it is a negative number, so we have to include that negative in front of our 4. And then how many would be left? Well, just 1. All right, so negative 4 and 1 over 54 would be our answer right there. Excellent. All right, last but not least, look carefully at the key at the right. So this original one right here is what it's saying. Which of these keys below could you create a spinning or rotating by the original key? Which keys could you create by flipping or reflecting the original key? All right, so we're basically looking at rotating, meaning like turning, right, in either direction, or reflecting, okay, over some axes or something, okay? So if I took up my original equation, or my original key in this case, and I what would I have to do to get it to look like this? Well, if it's normally like that, right? If I flipped it, right, so that these bottom keyholes are on the top, that looks to me like letter A. So that means that that would be a flip or a reflect. Okay, so that would be a reflection. Now this second one, I have to look at how would I get this to look like that? Well, I know that if I kind of like put a pencil down on here and like pretended like I was turning it, then it would end up, right, with the little key notches facing up, but the little hole thing would be on this other side. So that's what B would look like. So B would be a rotation. Okay. Let's see, thinking again, how could I make it look like letter C now? Again, if I imagine putting my pencil right in the middle of the keyhole and turning my key up so it's facing up on its end, that means that these little keyholes, right, would be facing like this direction. Okay, so that's what C looks like. So I know that that is a rotation again. All right, and then my last one, let's see. My last one, if I were to flip it around or like spin it around, the keys are going to be facing, or the little notches are going to be facing up. So that tells me for sure that I would have to do something different. So I think what I might have to do, right, is flip it. So if I flip it over, imagine it being flipped over onto its other side, then the keys are going to be facing down because we're not turning it at all. We're just flipping it over. So that means that this letter D is going to be a reflection. All right, great. If those are still confusing, let me know and we'll like work some more problems on here that are similar to it. I'll make some more videos. If that's confusing, just let me know in class or shoot me an email. All right, well, thank you guys so much for watching and we'll see you next time.